Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS, College of Process Science. So in this video session, we are going to discuss about a case analysis of for a bank ATM queuing model. So first, what is queuing system? What is queue? Queue is a waiting line. So what is waiting line? The customer, that means the people arrive the queue and getting the service, then he leave the queue. So it is a system. So in this systems we follow what are the happening in the ATM side. So queuing is a common word that means waiting line or an act of joining a line. So queuing theory includes the expected waiting time in the queue, the average time in the system, the expected queue length, as well as the probability of system to be certain states, such as empty or full. When the queue is full or when the queue is empty. So there is a case study is on queuing theory to study the waiting line in LTC Bank at Singapore and Ahmedabad. The bank provides one ATM in every branch. In ATM, bank customers arrive randomly and the service time is also random. They use the formula M1 model. So to derive arrive rate, service rate, utilization factor, and what is waiting line in the queue, waiting line in the system. So the problem statement is, on average, 600 customers are served on a week, that is Sunday to Thursday, and 300 customers are served on weeks, Friday and Saturday, monthly. General, on Saturday, there are no more customers coming to waiting during 10 to 6 p.m. So what are the basic characteristics of queuing system is input pattern, arrival pattern, service pattern, and queue discipline, then customer behavior. These four are important characteristics of a queuing system. The queuing system consists of one or more services provided service to arrive customers. The populations of customers may be finite or infinite. So many customers come and join the queue. The finite customers may be either finite or infinite. The finite means the capacity of the queue is either limited or unlimited. Bank is an example of unlimited queue length because so many customers come to bank and getting the service. So the ATM model, that is M1 queuing model, M1 queuing model means that the arrival and the service times are exponentially distributed. For an analysis of ATM, M1 queuing model, the following variables are investigated. So here we use lambda. Lambda means the number of customers arriving in the system, that is inter-arrival rate. So what is inter-arrival rate? The arrival of one customer to another customer. The time gap between one customer to another customer is called inter-arrival rate. That is calculated lambda. And mu is number of customers getting the service. It is calculated in the exponential. So these are all the different queuing model formulas. The lambda means mean customers arrival rate, and the mu is mean service rate. Rho is utilization factor. That means the system is always busy. And then the probability of zero customer in the ATM, because the ATM is sometimes free. That means no customer in the ATM. So that is probability for no customer in the system. That is P0. That is 1 minus rho. Rho is 1 minus the busy. And there are n customers in the ATM, that is rho over n into 1 minus rho. So using this important formula, we calculate the average number of customers in the ATM. That means length of the system. What is the length of the system?
Rho divided by 1 minus rho, and lambda is equal to mu.
Lambda by mu. Yes. It is length of the system. It is rho divided by 1 minus rho. Rho is lambda by mu. And similarly, you calculate length of the queue. That means except the server, the remaining customers in the queue, that is L2, that is rho square by 1 minus rho. And the waiting time in the queue, that is rho 1 by mu minus lambda. And the waiting time in the system is lambda by mu into mu minus lambda. These are all the important formulas to calculate the waiting time in the system, length of the system, waiting time in the queue, and the waiting time in the system. So now, observations and discussions. We have collected 1 month daily customers data observed during the bank time as well as here. Here there are 4 weeks and weekends, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday and Friday. In the first week of Saturday, there are 70 cut of customers arrived at ATM or bank, and Sunday there are 191 customers arrived at ATM or bank, and Monday 161 customers, Tuesday 120 customers, Wednesday 130 customers, and Thursday 111 customers, Friday 95 customers. And likewise second week, third week and the fourth week for this. So compare this all this data here. This Saturday and the Sunday the customers are increasing. The Saturday customers are 70, Sunday 170, 191, it will be increased. On second week the number of customers 75, on Sunday it will doubled in 154. Third week 65, but Sunday it is 140. But on the remaining case, Monday is also increased as well as the Sunday also. But a little bit of Tuesday, Wednesday, Thursday and Friday, the customers also decreased. In this table shows that the Saturday and the Sunday and the Monday, compare these 3 days, or automatically compare this Sunday and Monday, these 2 days our customers are busy in the system. So from the above figures, we observe that the number of customers on Sunday is double the number of customers on Saturday during the same month. So the busiest period for ATM is always Sunday and Monday during bank time, because bank time is 10 to 6 p.m. Hence, the time period is important for the research. So also we observe that after Sunday, the number of customers start decreasing slowly in the weekdays, because Sunday, next Monday is a peak hour. After that day, the customers arrive to bank or the ATM will be decreased. So on Saturday it is least. On Thursday and Friday, suppose it will be slightly decreased more than the Saturday. This is because of Friday and Saturday will be a holiday. Suppose we consider that. So the calculations we investigate above. After Saturday, during first 2 days of a week, there is an average of 60 people coming to the ATM in an hour period of banking time. So from we can derive the arrival rate, that is lambda, is 60 customers per day, 60 hours, so 60 minutes. So 60 by 60 is equal to 1 customer per minute to arrive at the ATM. Okay, here lambda means lambda is calculated here 60 by 60, that is 1 minute. So what is the length of the system? There are 2 customers to waiting and getting the service in 3 minutes. Likewise, this all are. So the length of the system is 1 customer per minute. So it takes 2 minutes to customers. So totally the waiting line in the system is 2 customers. And the new service, how many customers getting the service per minute? 1.5 customers per minute. Hence, the row, that means the system is busy, is lambda by u, that is equal to 1.5 customers per minute. So these are calculated from that. What is the empty in the system? That is P0, it is 1 minus row. So 1 minus already calculated the row value, it is 0.70, it is equal to 0.30. Is a possibility for the no customer in the system is 0.30, that is for 3%. So also we find from the observation discussions and got that each customer spends 2 minutes on an average of ATM. The queue length is around 3 people. Therefore, length of the queue is average or waiting time is around 2.5 minutes. That means 150 seconds. Theoretically, the average time is we have seen that the observation actual waiting time does not differ by the means of compared with the theoretical waiting time. So next we conclude. We calculate the average number of people in the ATM, having calculated the number of customers in the ATM. We can also derive the service rate and the utilization factors already derived. So in the utilization factor, that means the system is busy, is 0.70 duration spanning time. The probability for 0 customer in the system ATM is very small, as well as by the derivative. As the capacity of ATMs, 1 people, we can calculate the probability of 4 people in the system. Okay. Therefore, the probability of customers going away is P, that is equal to more than 3 people in the queue. Yes. So evaluation utilization is directly proportional with the mean number of customers. It means the number of customers will increase as utilization increases. The utilization rate at ATM is very high, that is 0.70. This, however, is only initiation rate during banking time on Sunday and Monday. On weekdays, initiation rate is almost half of it. Already calculated this. This is because the number of customers of weeks is only half of the number of people in the weekdays. In case the customer waiting time is lower, or in other words, he waited less than 150 seconds, the number of customers that are able to serve per minute will increase. So when the service rate is higher, utilization will be lower, which makes the probability of customer going away is decreases dramatically. Yes. So what is the benefit of this? This case study helps bank ATM to increase in quality service by anticipating if there are many customers in the queue. The result of this work may become reference to analyze the current system is improving the next system, because the bank can now estimate the number of customers placed in the queue and the number of customers going away each day. By estimating the number of customers coming and going in a day, the bank can set a target that how many ATMs are required to service the people for its main branch, or it is the other branches also in the bank. So the conclusions. In these conclusions, there's one customer per minute and the service rate is 1 customers per minute. So the probability of overflow is there are 3 or more customers in the queue, 10 out of 100 customers it will be increased. The concerns that the case study for bank ATM queue model is a reference. Face the completion of the research where the accuracy of result, since some of the data that we got just based on assumptions or approximations. We hope this research can contribute, or this case study can contribute to the betterment of the bank in terms of punctuation times. As our future work, we will develop a simulation model for the bank ATM also. So, the better, and then it is all for references. Thank you.
Thank you, sir.